Oh, guiding is still crappy. Why is that?
Okay, it started.
Okay. Maybe I should turn my guiding exposure up to a second and a half.
We'll just let people join in now. Okay. Well, okay, I think we're getting viewers now. Already.
You're getting what?
I think we're already getting viewers now.
Oh, really? Maybe I'm not in the right place. I'm not. Wait a second. I need to, what do I need to do to be able to see something? I'm not seeing it.
Well, refresh.
Just refresh? Okay.
We'll just let people join in.
Okay. Well, do I need to click on the icon? Uh, I'm not seeing the dashboard like, the.
There is no dashboard.
Wait a second. There's a little,
Just go to youtube.com, Google Curiosity Peak, and join.
oh, you know what? I'm on Doug though. I'm not on.
Yeah, you're not supposed to be joining to Curiosity Peak because I already did that.
Yeah, I know. Okay.
Just go to YouTube, Google Curiosity Peak, and then join.
You mean go to YouTube first, right?
Yeah.
I did that.
Yeah, then go the search bar Curiosity Peak Observatory.
Oh, okay. Okay, yeah. Okay, I did that. Oh, live now. I see it. Okay. It's down there. Okay. Yeah,
Yeah,
okay.
for people who just joining, we're starting at 10 minutes early to allow people to join in because we technically this was supposed to be yesterday. So
Yeah, right. Okay. All right. Hi, Lynn, and Chip. We're going to start at 8, but we are live right now, so just we can all hang out for a little bit and wait for people to join.
we've got 11 right now, so we're just gonna let it file in.
Okay.
Then at 8 o'clock we'll start the show.
Yeah.
So you can already see what we're doing, and you can already probably guess which one is which. So
Yeah. Anybody want to venture a guess?
yeah, this is not even. This is not.
Which one is Julian? Which one is San Marcos?
What if it's the one on the? What if the Julian is on the left?
Uh-huh. Well, then we'll have to move to San Marcos.
Yeah.
Move the observatory.
Yeah, we're gonna have more objects like this, but this is the first one.
Yeah. Well, anyway, for people who are watching, we are actually imaging right now from both locations.
Yeah, this is technically live view. We're both doing 1 minute exposures.
Yeah. These are through the telescope in both locations. Roughly the same setup, so that
Well,
we're not.
we'll talk about this when
Yeah.
it starts.
Yeah. Okay. But anyone who's already watching, if you want to just say who you are on the chat, it's always nice to know who's connecting with us and where you are. Gets our adrenaline going. Okay, Burning Man. I know who that is.
Mm-hmm.
I must say we're really glad we got good weather tonight because last night, it was. Yeah.
We still don't know about the marine layer.
Oh, for tonight, you
In
mean?
San Marcos. Yeah, that's gonna be a issue. It's right now very high humidity. I've got a
Is
do
it really?
here running.
Yeah.
Yeah.
Okay. Well, if you could just have your neighbor build a bonfire or something to ward it off for a little while. Well, I got a big wolf spider in here climbing around. I guess interested in the star party.
Yeah. I might edit when we put this on YouTube. I'll edit out the first 10 minutes.
Okay.
That's simple enough. Yeah. Okay, we've got. Right now right now at 12. Looks like, I don't know. Guiding's going all over the place.
Yeah, I'm having an issue with it.
Well, let me look at mine. Mine is at. I'm at 0.88. That's not 0.88.
Let's see if it settles.
On the right. Yes, it is. I mean, yeah. The left looks kind of sad in comparison if you look at the image. We'll talk about this soon.
Okay, Lynn, you are right. That's Curiosity Peak on the right.
And then my setup on the left. We'll talk about this.
Yeah, that's San Marcos Peak.
Okay.
Okay, I'm gonna open that.
Okay. We're almost at 8 o'clock soon. We'll start then. Looks like I don't see any hint of the marine layer yet, but it's very humid. It's not dripping wet, but I can feel it. Hopefully it don't get soaked in. That'd be bad.
Yeah, well, we might have to revise our plans. Oh, Borrego Springs. Hi, Janet. Welcome.
Okay, so okay. Hopefully people got the memo that it got switched. The day they got switched, because yesterday it was just bad for both of us.
Yeah. Yeah, just for the Borrego Springs people, I just want to apologize for not having something up there to tell you that we changed the date. Since
I put it up today.
Yeah, right. I know. I'm just, wanted to say something.
Yeah.
Glad you could make it. We really appreciate that Betsy has, put the word out in the Admin newsletter.
Yeah. That's great progress. Okay, we're at 15, almost about to start. Okay, my writing's constant. My OAG is out of focus, but I don't care right now.
Okay, well, image doesn't look too bad.
I mean, it's 2 arc seconds per pixel. It's okay. 0.88 guiding is good enough. Okay. It's almost. Okay. Ready?
Yeah.
Okay, we got it. Someone from Washington.
Oh, wow. Okay. Hello, Rick. Yeah, welcome.
Okay, we're almost ready to start. I mean, it's a little more structured today.
Huh?
The star party is a little more structured than usual.
More structured?
Yeah.
Yeah. Well, we're a little more prepared too.
Oh yeah, guiding issues. Okay, it's 8
Yeah.
o'clock. I think we can start.
Yeah. Okay.
Okay. All right.
Yeah. Okay. Well, I just want to welcome everybody who's online with us. This is Doug Salty and Julian at Curiosity Peak, and you want to introduce yourself?
Okay, so I'll talk about what we're trying to do here.
Yeah.
Okay, so first of all.
Well, introduce yourself.
Okay. Yeah. Well. Yeah. I'm Vivek Vijay Kumar. I'm in San Marcos with my setup, looking at. We're gonna look at the same objects as Doug, and trying to compare, see how bad it is over here compared to Curiosity Peak. So, to start, I want to show this picture because this is a comparison I did from Curiosity Peak at the left, obviously, which is on the Bortle scale from 1 to 9. It's around 3, because on the Bortle scale, 1 is the darkest and 9 is the most light polluted. So this one's Bortle 3. On the right, it's Bortle 7, which is San Marcos. So these are same exact exposure times and same exact equipment. And this is the same exact processing. So what you can obviously see here is, it's all orange. But for this star party, we're going to try to remove this orange to really see how badly light pollution affects the image itself. Because the orange is pretty easy to process out. It's just how much it destroys the signal compared to Curiosity Peak. So that's what we're showing here. We've got Doug's setup on the right and my setup on the left in San Marcos. It kind of looks like this was actually taken before. That's the setup. Similar. I've got a refractor with the color cooled camera on a mount, and Doug has the same exact similar setup. He's got it's a little slightly the different characteristics, but we're trying to make it as fair as possible to adequately show the difference between San Marcos and Julian in terms of how light pollution affects the image. So, geez, the guiding's not that good, but okay, yeah. So here's an object. It's called a Cygnus Wall. Cygnus Wall. It's in the North American Nebula, if you're familiar with that. And it's just your standard hydrogen alpha emitting nebula, and yeah. So on the left, that's San Marcos. On the right, it's Curiosity Peak, and the difference is there. Of course, Doug, seems like the guiding isn't.
Yeah. Yeah. Image is a little blurred. We're doing what's called looping, which means we're taking 60-second exposures continuously. So every 60 seconds, there's a new image. So you can see the image on the right in a second will get a lot sharper because
it's already.
Yeah, well, it's...
Okay, yeah, that's better.
Uh-huh.
Slightly better, yeah.
Yeah.
Okay, but
anyway, the differences that you see through the telescope would correspond to the difference in looking up with your eyes or binoculars at the night sky. It's just that when we have a fairly faint object like a nebula, it's a lot... You can really see a lot of difference because of the detail, the color, the amount of contrast. All those things are really important factors, whether you're just lying back to look at a meteor shower and the Milky Way, or whether you're imaging through a telescope, or if you're looking through binoculars. It all comes out the same kind of difference.
Yeah, so it's a pretty stark difference if you compare the two images. It's just the one in San Marcos is just a shadow of itself compared to the one on the right. I also want to stress we're kind of trying to color balance it. So if it was a true color balance, the one on the left will look just orange. So we're just trying to account for that through processing, but the difference in we're trying to show the difference in signal and contrast, and it's very stark that the one on the right is much better.
Yeah, maybe you could say something about why orange, why the color is thrown on.
So the reason why it's orange is mostly the contribution of sodium vapor and those sodium vapor and mercury lights, and that's what makes the light pollution a little more orange, especially in San Marcos because we have quite a lot of sodium vapor around us. But yeah, so that's really that's really what's causing this very huge difference between the two images. Yeah.
Yeah. I mean, I think one of the most important things is the contrast. You really see a dark background on the right, and the nebula jumps out, and it's just like looking up with your eyes at the Milky Way. If you're say you're in a Ramona or somewhere that's kind of in between, like where Vivek is and where I am, then you might see the Milky Way, but it wouldn't jump out at you very much because the background is not that dark.
Yeah.
And on the other hand, if you get out to someplace that's even darker than Julian, the Milky Way will just jump out at you and almost scary. You haven't seen it. Yeah. Also, want to just say hello. We got Sherry grew up in San Marcos. I'm not sure where she is now with us, and Carrie Schneider from San Diego. Welcome.
Well, we got 40 people watching, so that's quite a lot.
Wow. Okay.
Okay, I think we're ready to move on to the next object because unless people have questions about what we're showing, but I think it's pretty clear what light pollution is doing to this nebula.
Yeah. Also, if you have any question about the particular, subject that we're looking at, we certainly could talk about that a little bit. We don't want to. We got several objects to go through, but
Yeah.
And there's Sherry from Manhattan Beach. Great.
Yeah.
Okay. Anyway, this is in the Milky Way. It's in the constellation Cygnus, and this is it's kind of a close up of a area that's called the North American Nebula because it actually looks like North America, United States and Mexico together, although this is upside down.
More Central America.
Yeah, this would kind of be Central America. But if you Google or the North American Nebula, you will see what the whole thing looks like, or join in one of our other star parties where we use a wider field. And we will be having another star party next Saturday.
Yeah. Okay, let's move.
Okay, move on.
Yeah.
Okay, we're gonna take us a minute to get to the next object.
It's the big switcheroo.
Where to go? Okay.
What's the next object?
VDB 126.
Okay, we're gonna have to pull out the X dot.
Yeah. Okay.
Okay.
Okay. VDB 126. Okay, there it is. Okay. Yeah. So we're going through the paces here of. Okay.
Switcheroo.
Now the telescope to its next destination.
Yep.
What happened? Wait a second here. Oh. I don't think it did it. It's doing. It's doing North America again. Wait a second.
Okay, you need to load the file.
Yeah, I did, but.
Okay, while you're working on that, I'm getting.
Okay. Yeah. Okay.
Is it going there?
Yeah, I think so. I hope so. It's moving. Is this in the west?
Yes.
Okay. Say, because it's going pretty far west. Okay, now it's going up a little higher.
I'm getting a little bit. There's a little buffering. Hello?
Yeah.
We're getting a little bit of buffering.
Are we? Yeah. Okay. Well, we got 45 people with us. Well, I'm really glad to have. This is the largest crowd we've had so far. So, 49 people. Wow. Okay.
Yeah, I'll just wait for the screen to go back.
Okay. Now, what you're seeing on the screen, the camera's taking pictures, and the computer is telling it if it needs to move a little bit to get the object centered. So it does a kind of a feedback process. It's called plate solving, and it compares what the camera sees with where it should be.
Okay.
So usually,
I'm almost ready.
Okay. Yeah. Okay.
Are you?
It's exposing. Oops, it's doing 120 seconds. Okay, I need to stop that and start looping. And,
yeah, I need to stop the sequence.
Yeah. Okay. Okay. So we're gonna do 60-second exposures again. Okay, starting now. So
am I guiding?
Yeah. Okay, what you're.
It is buffering.
There is the guide camera. We have each of us has a camera and a little, and that focus. It locks onto a star, and it keeps telling the mount what to do to keep locked onto that, right on that target. So we want it to be really.
Okay, we're back to our stream is back to good health.
Huh?
Our stream is back to good health, and it's bad again. Great. Oh. We're getting a little buffering. Okay. Are you? Okay, you're on it now.
Yeah, I'm on it. I'm almost done with the first exposure, so we should be seeing something in a second here. We're at 59, 60 seconds, so you should see whatever I see on the screen. Okay, there it is. Yeah.
Oh yeah. Okay. Doug, if you don't recognize, I've imaged this before.
Yeah, this isn't the propeller, is it? Or
no.
Okay, this is a dark. What we're seeing is dark nebula.
It's a reflection nebula in a dark nebula.
Okay.
So I've got it centered, and oh my goodness, great! This is amazing. Yeah.
That's the reflection nebula around that star.
Yeah, but if you're looking at if you're seeing the version that I have, it's a little sadder, to say.
Okay.
It doesn't even look the same, to be honest. Okay, I've got them compared, but it's just not a comparison. You can't even see. I don't think you can really see the reflection nebula from San Marcos.
No.
It's not visible. I mean, you can in the Julian photograph you can see the blue around the reflection. You'll notice that you can see that blue, but in the version from San Marcos, it's not even there. So.
Yeah, one thing about even imaging or looking for things like this, dark nebula and so on, it's really, unless you're in a dark place, you just can't. You just don't see it, as you can see from Vivek's image.
Yeah, you can see it, Doug, right?
Yeah, I can see it.
Yeah, it's just not a comparison. It's the Julian one just looks. You can see more stars, obviously. I think people can see that.
Yeah.
There's more stars.
Those dark areas are areas of dust that are blocking out the view of the stars in the Milky Way. That's why they're dark. It's just that they're blocked. And those are some of the more subtle things that we enjoy seeing and, discovering or rediscovering when we image and look through the telescope.
Yeah, this is Yeah, the dark nebulae, they're very impacted by light pollution. It's just a higher
Yeah.
contrast and higher visibility on the Julian image. This one, the San Marcos one, is just it's not even really there.
Yeah. Yeah, so some of these things are the more subtle things that are very interesting to be able to see. Now you could see I imagine if you were doing visual astronomy, maybe you'd be able to see the North American Nebula. Do you think?
No,
Or you wouldn't even be able to see it through the telescope.
yeah, you need dark skies for that.
Yeah,
We're doing imaging, so it's more you can see the North America with the camera, but it's just as obviously saw in the last object, it's heavily affected, and so is this one. It's like you can't even see the reflection nebula from San Marcos. It's just not there.
yeah. Now something worth thinking about is that, maybe 30, 40 years ago, or more than that, like Escondido, or Poway, you could see these things or image these things quite well, but because of the growth of light pollution, those areas that used to be fairly dark are now really, just saturated with bad light that's going up into the sky and reflecting back down.
Yeah.
And that's what really affects your view of the sky. It isn't just the light that hits your eyes from nearby lighting, but it's all the aggregate light that's shining up into the sky is reflected back down by dust particles and water vapor, and that's what creates that light dome that obscures what we're looking at on the right.
Okay,
But we're looking at it on both sides. Yeah.
We got a question from the chat. What telescopes and cameras are using at each site? So,
Okay.
as previously discussed, we try to make them as very similar, and here's a picture from before. If you want more specific information, I have an 80mm refractor with the ASI 533 MC Pro, while Doug has my 115mm refractor with his ASI 294 MC Pro. So we try to balance out the light per pixel so that you can make a good comparison between these two. Because we obviously we don't really have the identical cameras, so we try to balance it out with the telescope.
Yeah, we don't have duplicate equipment, but we're trying to compensate so that it's a fair comparison.
Yeah, but I mean, it's pretty clear that I think it's becoming pretty clear how bad San Marcos is being for our purposes.
Yeah, they're both color cameras.
Yeah.
So it isn't you're not seeing color on the left because it's the camera is perfectly capable of showing color. It's just that the color is washed out.
Yeah, and you can't even see the reflection nebula. You can see it you can see both of the reflection nebulae on the Julian version, but on the San Marcos version, it just doesn't exist. So, all right, I think we can go to the next object.
Okay, I guess yeah.
Which one is it?
Okay, it's the next one is M31. Okay.
Okay, that's simple enough.
Yeah. Okay.
Just make sure to stop looping.
Yeah. Okay, I did. Okay, and we'll go to sequence and M31.
Nina still refers to it as the Andromeda Nebula.
Yeah. Well, that was before it was proven beyond a doubt that it was a galaxy.
Yeah, that's the name before.
Yeah.
It was proven in like the 1930s, 1920s.
Really? I thought it was earlier, but it took that long. Okay.
Well, yeah, the Harlow-Shapley debates were in the 20th century.
Yeah.
Okay. I've slewed there.
Okay.
It's gonna start plate solving. Plate solving is just trying to take an image, see if the object's there, and using that to center the object.
Wait, for some reason it didn't slew to M31.
Did it slew? Are you sure?
Yeah, because it's pointed in the same place. Wait, I'm going to stop it.
Okay, I'll let you.
Oh, I think I know what.
I'll let you get to that.
That's 19 hours, 26 minutes, 9 seconds, RA.
What? RA, center RA. I don't think so. I don't know. Okay, well I got the Andromeda on my camera now. The RA is supposed to be 1 hour. It's supposed to be around 39 arc minutes, 0 degrees.
Yeah.
Okay, I'll just let this center.
Mine seems to not. It's not going to M31.
Oh, by the way, if people, just for clarity, neither of us are using any light pollution filters. So this is just UV IR cut. And even if we did use light pollution filters, their efficacy is kind of, they're not very effective with given how much LED we have right now. So okay, it's almost centered.
Okay. Okay, it's going. I think I typed a space between M and 31. That was probably the problem.
Okay. Yeah, don't. I guess don't.
Typing error.
For some reason, it's getting stuck on start guiding for me.
Well, you got an image there.
Okay. Apparently now it wants to start guiding. Okay. Okay, I'm gonna start my 60 seconds. I'll let you get.
Okay. Yeah. Okay. It's plate solving.
Quite a lot of the start party will just be moving to the object. It is what it is.
Okay. Yeah. Okay. Well, we got it framed nicely. So some of you may be familiar with this object because we looked at it at the last star party, I believe.
Yes,
or did
we did, I think.
We
did. Yeah. So we'll get the San Marcos and the Julian version now.
Okay.
And
I see San Marcos. Well, we can see
that's just the plate solving. That's a 1 second exposure.
Oh, okay. Yeah.
The 60 seconds is still going.
Right. Okay. Okay. We appreciate everybody's patience. We have to. It's not instantaneous getting the scope to
2 setups
centered on the object and then.
Yeah, you have to keep in mind there's 2 setups that are going right now. And mine just finished, so we have the San Marcos version, which isn't that bad. But we'll see how much the Julian version humbles it. Okay.
Yeah, well, we can see quite a bit of it there. Yeah, okay. So we're doing...
okay.
We're doing 60 seconds, right? Yeah, okay.
So yeah, just get started.
Each setup is doing 60-second exposures continuously. So these aren't being stacked. They're just individual frames.
Yeah.
So before, when we showed you things that we were stacking, that meant we were taking multiple images and they were being combined to actually enhance the image, the contrast and the detail, the color and all that.
Yeah, so yeah, we're looking at the Andromeda Galaxy.
Okay.
Yeah.
Okay.
Answering your question in the chat. Okay, yeah. I'll let you get your exposure done.
Okay, yeah, it's about 20 seconds to go.
Yeah.
Oh, well, Betsy, welcome. Okay. Okay, Betsy wants to know a little more about the Andromeda. Well, it's the closest major galaxy to our Milky Way, and it's about 2 or 2.5 million light years away. It has 2 satellite galaxies, which you can see above in the upper part of the image and then the lower left. It's roughly the same size as the Milky Way, and it's a spiral galaxy like our galaxy is. The dark areas are dust lanes. Those are areas of where there's dark
Yep.
material dust that blocks the light. Um, they both have a black hole at the center, or the Milky Way does, and Andromeda Galaxy. And our two galaxies are on a collision course to merge or graze each other or distort each other. So in a, what is it, how many, few million years, or is it
No,
billions?
billions.
Billions. They're going to pass through each other and probably radically change their shapes and
They'll combine into one elliptical galaxy, Milkomeda.
Yeah, you think so?
Well, that is what's gonna. That's what we've termed it. Yeah, Milkomeda.
Milkomeda, okay.
But anyways,
yeah,
the comparison is the comparison.
Yeah. Okay. Yeah. Well, now we got the image. Okay, so you can see the Julian image and the San Marcos image side by side.
I mean, the San Marcos image just looks like it just doesn't look good, does it?
Yeah. But I just want to say, if you live in a place like that, it's still worth looking up at the sky and seeing what you can see.
I mean,
don't feel like I can never get into astronomy because of where I live. You can, but once you do, you will want to come out to a dark sky place and really see things even more vividly.
Well, keep in mind, this is still for 60 seconds, this is still pretty good Andromeda. And if I took a longer exposures and stacked them, it'll get even better. It's just that, this is just, we're trying to stress the importance of light pollution in terms of, I mean,
and Betsy, I don't know if you want to say, maybe make some comments about light pollution, since you have been involved in trying to reduce light pollution for at least 10 years now. I think we need to give people some perspective on what can we do about it.
But I can pretty clearly say that the Julian version wins.
Yeah, but right now, just to update people on what's happening, the county of San Diego County is taking light pollution more seriously, and we have engaged with the county to create a new lighting ordinance, and the Borrego Springs Dark Sky Coalition has been a very important part of that too. And we're actually they're creating an amendment to the existing ordinance that will recognize the importance of dark sky communities and enable dark sky communities to have a lighting ordinance which will prevent those communities from losing their dark skies. Of course, it really depends a lot, not just on what happens in those communities, but what people do, like throughout San Diego County. We, eventually, before too long, the county is going to revise its entire lighting code, and lighting doesn't last forever. So people have to replace old lighting with new lighting, and the purpose of this, amendment and future revision is to get policy made so that people will be using much better lighting. It'll be shielded. It won't be as blue, which is the worst kind of lighting for your eyes, your health, and the night sky. And so there, by doing this, by education and changing policies, I think we can take back, some of what we've lost. Obviously, the cities are never going to be as dark as out in the back country, but they could be a lot better. And people deserve that. They deserve to be able to have kids look up and actually be stimulated by the sight of the Milky Way and have their curiosity piqued. And also, it's better for your health, better for your sleep at night, and better for the wildlife. So encourage people to, communicate with San Diego County and the city of San Diego, the city of Escondido, Poway. All these cities can and should improve their lighting policies. It'll make a big difference.
Yep. Yeah.
And check out the International Dark Sky Association's website. It's full of useful information to help you understand and do something about light pollution and preserving or retaking our natural darkness.
Okay. I've zoomed in on M110.
Yeah.
Well,
Okay.
go back to M10. I had it on.
Oh, you wanted to zoom. Okay.
I have it. I have a
Yeah.
yeah. I have a comparison for this right now
Okay.
between the one in San Marcos and Jillian. It's a little. I mean, it's pretty clear. You can barely see M110 from San Marcos. So.
Yeah.
Uh,
And that's a satellite galaxy of the Andromeda Galaxy. It's
yeah.
actually orbiting around the galaxy.
Yeah. Okay. All right. I think we're ready to move on now that we've
Okay. The
pretty
next
clear,
is the
pretty clear
Crescent Nebula.
comparison.
Yeah. Okay. So we're going to go to the Crescent Nebula now.
Yeah.
That's 688.
Yeah.
8. Yeah. Okay.
And we're swinging back and forth across the meridian.
Yeah. Okay.
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 I'll just.
I'll
Give you a sec to get
I
there.
think my typing was a little better this time. I didn't put in a space. Okay. Yeah, so we're heading over to the western part of the sky now. The Crescent Nebula is in Cygnus. Am I right?
Yeah.
Yeah, which is the Milky Way. Cygnus is one of the main constellations in the Milky Way.
Yeah.
And it's a very, very good area of the sky to look at with binoculars or a telescope. And the Crescent Nebula is a fairly faint object, right? It's not.
Yeah, it's on the fainter side. So it's basically gonna be barely see versus good image from based on what we've seen so far. Yeah, I can't even. Oh, I see it now. Okay, it's in the field of view now. I don't know if people can have noticed it, but it's there.
Mm-hmm.
Yeah. Okay, let me know when you're centered.
Okay, we got a good comment from Betsy about things that people can do to practice better lighting. And an example goes a long way.
Okay, you started guiding?
Yeah, okay, I need to stop.
Make sure to turn off the sequence.
Okay.
I'm still plate solving, so.
Yeah, okay.
Almost done. Okay, and starting to buffer again. Every time we go to a new object, it just buffers.
Okay, now you're gonna, just a second, there's a little bit of a lag in our transmission of what's on the screen.
Yeah, there is. There's quite a lot of stuff running right now, so. It's expected. It's okay. It's good enough though. Okay, I've got mine running, so I'll let you get yours running.
Okay. Okay, yeah. For people who are watching the right side, you see a little bit of the Crescent Nebula there. Now that's just a few seconds exposure because, well, it was taking images of a few seconds in order to get the object centered in the field of view. So
let's zoom in on. I'll get yours.
You can see a little bit of color there, that red, but in about 2 seconds, well, there's a lag, so I see it before you do. Okay.
Okay.
Okay, there's the crescent.
There's a very nice image from Julian, and mine's gonna load in 14 seconds.
Okay.
Yeah. Well, you won't see it yet, but it's gonna be there soon, and it's gonna look pretty. It's gonna be a little. Okay. Okay, I've got my image and your image now. Left is San Marcos, as probably already know, but yeah, it's.
Yeah, you can barely see it. It's there, but not.
Are you looking at the plate solved image, Doug, or are you looking at the 60 seconds?
Oh, I guess with yours, I'm seeing the plate solving. Probably
Yeah,
still.
give it a.
Okay.
I already passed plate solving, so.
Okay, so we'll see Vivek's image in just a.
Well, they're
little.
seeing it right now.
Oh, they're seeing it now. Okay.
Well, in this point of the stream, they'll be seeing it, so. Gotta keep the lag straight. Yeah, so. Just talk about the present right now, but. Yeah, so the left. Yeah, the Crescent is a lot higher signal to noise ratio. It's just not. It's not much of a comparison in terms of. Yeah, it's very different view of the Crescent. I'm sure if we take longer exposures, it will show more, but the subjects do. They're very impacted by light pollution. And if you already noticed, people can probably notice, but there's a lot less stars in the San Marcos image because of light pollution. So that's important. And I mean, you can also see more of the dust and all the contrast in the Julian image. So it's a pretty stark comparison. Okay, and we didn't talk about what this object is. We should do that.
Yeah. Okay.
Okay. Yeah. So the Crescent Nebula. I mean, if you tuned into the star parties before, we've done this nebula before, and the spectroscopy star party, we actually looked at the central star of this nebula. This is the Crescent Nebula has got a Wolf-Rayet star at the center, and that's been outgassing a lot of gas and creating this nebula. So that's what this object is. It's a nebula caused by this Wolf-Rayet star at the very center, and that's produced this nebula. And it's mostly hydrogen alpha emission. So that's
not it's not the result of a nova.
No, the star is still there. It's it's the central star. It's a Wolf-Rayet star. If people remember what that is from the last star party. Yeah, but the comparison for light pollution it's a lot better in Julian, as expected.
Yeah. Okay, well, we got Christopher from Borrego Springs. Well, great, we got a number of Borrego people, so glad you guys all made it. And we did have to postpone because of weather, as you probably know. We just had clouds and marine layer last night, and we're so far good tonight. Okay, so
if anybody we can move on to the next object if nobody has questions.
Okay, all right. Yeah, we're going to go to another familiar object, the Dumbbell Nebula.
That's okay. Let's
okay.
Remember, no space.
Huh?
No space.
No space, right? Okay, no space in space. Okay, so M27 dumbbell. Okay, telescope is obediently moving, at least slightly. Yeah, it's
back to plate solving.
Not too far away, I guess, right? The dumbbell and the crescent.
Nope, same.
They're in the same part of the sky.
The summer triangle.
Yeah.
That's the triangle of 3 stars: Vega, Altair, and Deneb. And Deneb is in Cygnus, Vega is in Lyra, the Lyre, and Altair is in Aquila, the Eagle. Those make a very big right-angled triangle in the sky. It's called a summer triangle because it's around during the summer part of the year.
Yeah.
And I'm on M27 now. It's hasn't
Okay. I
started
am.
exposure yet.
Okay, we're plate solving, and if you. Okay.
Should start guiding soon if it works.
Yeah. Okay. Guiding. Okay. And start exposure. Okay. Yeah. But we already got a pretty decent image even from the short plate solving image.
Well, that's not. We'll make the comparison soon.
Okay.
Okay. Okay. I started my loop. Get started on the loop then. Okay.
Okay.
Okay. I'm gonna blow up your image onto the same
Okay.
scale.
It's blocked on the screen. You can kind of adjust the split screen.
Well, that was when we were plate solving. It doesn't matter.
Yeah. Okay.
Okay. We'll let the images roll in.
Okay. 30 seconds to go, and we'll have the first 1 minute image on my side.
And I have 15 seconds to go.
Yeah, but what happened? Something happened with my. Oh.
You mean the stream?
Yeah. Okay. It's back.
That was PhD 2.
That was what?
That was my PhD 2.
Oh, okay. Okay.
Mine just rolled in.
Yeah.
Okay.
Okay. Okay. Now this is a somewhat brighter object.
Yeah.
So.
Okay. Oh my goodness. Yeah, that's a very bright image. Yeah.
Yeah.
Okay.
Yeah.
For people. Yeah.
Yeah, I was just going to say, this is an object that you can see with a small telescope, even in suburbia.
Yeah.
You see it. It's not going to be in color with your eye. It's one thing about, everyone needs to understand the camera is able to see color much better than our human eyes can because of our eyes don't see color when we're looking at things at night very well.
Yeah, for Lynn, this is M27 the Dumbbell Nebula. It's a planetary nebula that we've covered before, but this one is caused by the central star is it's like it used to be a low mass star that then shed its outer layers to produce a nebula, while its core got crushed into a white dwarf. So that's what this object is. But if you're comparing the images, it's much more contrasted. You can see more fainter detail. It's much brighter in the Julian image, and you see a lot of stars. But in the San Marcos image, it's just there's not that many stars, and then we have the nebula is a little more attenuated. So, yeah, pretty good comparison of how light pollution affects this object.
And this object is in the same constellation as Altair in Aquila, the eagle.
No, it's in Vulpecula.
Oh, it's in Vulpecula. Okay.
The fox.
The fox. Okay. So, but it's not too far from Altair, right? It's kind of.
It's closer to Lyra.
Oh, closer to Lyra. Okay.
But
the Vega part of the triangle. Yeah.
Well, if you have a slightly larger telescope, say like 8 or 10 inch, like a Dobsonian, then you can start to see color on this nebula. But it'll just be like blue or green, because that's much more energetic, and our eyes more easily respond to that.
To the blue.
Yeah, so you can start to see that color with the larger aperture telescope. But yeah, I mean, the effect of light pollution is pretty clear.
Okay, so Lynn, hopefully Vivek answered your question. What are we seeing now? Okay.
I think we can move on.
Okay, all right. So
what's the next?
B142, the E
Okay.
nebula.
Okay, that's a dark nebula.
Right.
So I'm just gonna assume that nothing will show up on my end.
Okay.
It's called the E nebula.
Okay. And what part of the sky is that in?
Oh, it's in Aquila.
Okay. Okay. Yeah, the telescope didn't move very much. Oops. Wait a second. I think it didn't because it's still trying to go to the dumbbell. Okay, I'm gonna stop that.
What makes the blue color of the dumbbell? We got a question from Betsy Kanak about what makes the blue color. If you're referring to the dumbbell nebula, that is from oxygen in the dumbbell nebula. That it's oxygen and it emits at a wavelength around that basically makes that we would consider to be like teal, and that produces the color of the dumbbell. But if you're referring to reflection nebulae, that's due to Rayleigh scattering, which is the same phenomena which is why the sky is blue. So I don't know which one you're referring to, but I hope I answered the question. Okay.
Oh wait.
Okay. I've started guiding. I'm gonna. Are you there yet?
No, I'm almost getting it.
You did your slew to target, center target, and start guiding are not on.
Oh, why is that? Okay, jeez.
Because you loaded a new XML file, so you need to turn those on.
Yeah. Okay. So I need to stop this in order to do that.
Yes.
Okay.
So make sure. Yeah.
Okay. Okay.
You turn both.
We usually don't do this many objects this quickly, so it's a little bit of a sprint. Okay, I moved, so I think we're in the right place. Yeah.
Dumbbell Nebula O2. It's oxygen 3. That refers to the oxygen being doubly ionized. So that's
the same as ozone, right? O3.
No, we're talking about oxygen 3. The O3.
But isn't O3 the same thing as ozone?
No, we're talking about like oxygen 3, like in terms of
light
nebulae.
Yeah, right. But does that mean the light is coming from the element that's emitting the light?
Oxygen 3 refers to O and then III in Roman numerals. And that means it's an oxygen radical, one single oxygen atom that's been ionized twice. So it has 2 electrons removed from it. So that we call that oxygen 3 in spectroscopy. So that's doubly ionized oxygen, and that's the atom that's producing the teal wavelength in the Dumbbell Nebula. O3, like in terms of like 3 atoms, that's ozone. But when we're talking about
it's three atoms of ozone. I mean of oxygen.
Yeah, but in the terms of spectroscopy, we have sulfur 2, oxygen 3, nitrogen 2. Those aren't referring to the number of atoms. Those are referring to how many electrons have been ionized. So if it was oxygen 1, that means that the oxygen is not ionized. It's neutral. If we're talking about oxygen 2, that means an electron's been removed. So that's what that naming system is.
Okay, thank you. Tell how my high school chemistry has not been entirely retained.
Okay, I've already started looping, so hopefully you're...
Okay, yeah, I've started too. It's getting there. Another Another 25 seconds to go.
And
So what kind of object is this? This is one that I've known.
it's a dark nebula.
Okay.
It's the shape of an E.
Oh.
And as expected, I can't even see it. I think I can kind of see something, but I really can't see it. So hopefully it delivers on your end.
Yeah, well, dark nebula is something you don't even have a chance of seeing unless you're in or of even imaging.
Well, okay.
Okay.
Can you see something there?
Yeah. Well, okay. That's the area right around there. Okay.
Yeah, that's right. It's a little faint though.
Yeah, it's not entirely dark. I guess it's there. It's.
Do you want to? Do you want to take? Do you want to take 2-minute exposures?
Okay, we could do that. Sure. Okay.
Then, yeah.
Well, might be a little. Okay, we'll both do 2-minute exposure.
Yeah, I started.
Okay. Okay, we're gonna.
Seems like it's a little faint.
We're gonna double the exposure time.
Yeah.
Light.
Yeah, this is the dark nebula shaped like an E, so it's called the E nebula. Very cool.
Okay. And what constellation is it in again?
Aquila.
Aquila, okay.
I don't think I really have a chance of seeing it, so interesting.
Yeah, well, this is where we can really see the difference then.
I kind of think I can see it. I don't know. We'll see. I think the 2-minute will be a better rule.
Yeah. Okay. So it does take a little patience, but hey, this is a lot better than shooting images on film, having to wait for them to be developed to find out if you actually got what you wanted,
or having only like 5 to 10% quantum efficiency.
Yeah. The days when people did astrophotography with film cameras, they did it, but it was a lot harder.
Yeah.
Digital photography has created a revolution in astronomy. There's no question about that.
And that does help with light pollution, because you're able to find ways around light pollution. Even though the data is not going to be as good, you make the best you can out of it.
Yeah. Now I'm seeing some red in the image so far. Is it at the center?
I don't know what that is.
Oh, no? Okay. Well, it's probably hydrogen, I imagine.
I've seen an image. I don't think there's supposed to be any hydrogen there.
Oh, really? Well,
I'm not sure what that is.
Yeah.
Maybe a gradient.
Well, but it's in just a couple of areas of the image. It's not everywhere.
Okay, I think I can start to see something of the E. The thing is showing up. I'm not sure, though. We'll see when your image is...
Okay, it's almost done. Okay, I think it is done. So let's...
What even is there? Interesting.
Yeah. Well, I see an E on the upper...
That might be it.
You see where my cursor is? Is that it?
I don't see your...
I'm guessing because I've never looked at this object.
You mean here?
Yeah, over here, right. See,
I think that's it. Yeah, I think we're a little off center, but...
Yeah, okay.
Interesting. It's not like I can tell anything from the center of this image. It just looks like... just looks all over the place, but...
Yeah, it's well, I mean, you just don't... You see a lot of areas that look kind of... like there's some... like a nebula or something, just kind of whitish... Yeah,
but that's just all light pollution gradients.
Maybe you could say something. What is a gradient? Because I don't know if everybody...
A gradient is like, like different parts of the image being brighter than others due to just light pollution. So that's a artifacting that's very hard to, pretty difficult to deal with because of light pollution. But another thing I think people noticed is I have a square camera. And has a rectangle, so keep that in mind in the comparison. Okay, I think we can go to the next object. I mean,
Okay,
I
no,
can't even
no
see
questions.
anything here.
Okay, all right.
This
Okay,
looks
next,
better.
yeah. Okay, next object is the Cocoon Nebula.
That should be interesting.
Yeah. Okay, and this is a very photogenic target. A lot of people image it because it has a lot of color.
Make sure to turn off looping.
Okay, and I thought I did, but I'll make sure.
Okay. And also, we're gonna use 60 seconds now for.
Okay, yeah. Okay, yeah. So we'll need to change that. Okay.
And so it's gonna be a long slew.
IC, let's see, that's IC 5146.
Yeah, I'm there. I'll let you get to your sequence.
Okay, it's moving considerably.
We've
It's going to the other side of the meridian.
yeah, we're doing a lot of meridian flips today. Quite literally going all over the place. Okay, it's almost there.
It's pretty close to the meridian, just on the eastern side of it.
Yeah, it's probably gonna meridian flip in like 30 minutes or something. Okay, I see it now. Okay. This will be a very interesting object for this. Oh yeah, I see it pretty well. Even from light pollution.
Next week we're going to look at Mars. Right?
Yeah, we are.
Among other things. So we got another star party next Saturday. You know, the sky is changing as we're getting towards winter.
Okay. Right, I think mine's about to start.
Okay, so 60 seconds this time.
Okay, I'm gonna. Yeah, 60 seconds. Okay, I think we can. Let me zoom in on mine. I think that's appropriate.
One of the things it'll be interesting to see how much color we can see because this is a pretty colorful target.
Yeah, it is. It's a very interesting target.
And is this is in Cygnus?
Yeah.
Swan.
Large.
Okay.
Okay.
Okay, I think I can barely see it in the center just from that few second exposure. Okay, we're 20 seconds away from having a 1 minute exposure.
Same. Though I'm 1 second ahead of you.
Okay. Race to the finish line.
And yeah, they're gonna pop up at around the same time.
Okay.
Oh my goodness. Okay, that's interesting. Oh, come on.
Matter.
Come on.
There's nothing there.
No, I saw mine. I thought, oh, that's pretty good. And then I saw yours pop up. I was like, oh my goodness, what?
Yeah. Okay. Yeah, I can see some color there.
On yours?
Detail. Yeah, detail.
I can see the red on mine, and that's pretty much it. Actually, zoom in on the cocoon itself. I think that'll be a pretty good comparison. Yeah. This is a very interesting example of light pollution, to say the least. I don't think that you can see this yet, Doug, but yeah, you can see the cocoon pretty well in yours. You can even see a bit of the reflection around it.
Mm-hmm.
That blue, the characteristic blue. But on mine, it's just some red stuff. And that's it. So, it's a pretty stark example. Maybe,
Yeah.
how about we try 2 minutes?
2 minutes? Okay.
Let's try 2 minutes on this one. That'll be...
Hey, what's going on with my mouse? Well,
That being said, there's also dark nebula around the cocoon, which I think people can see due to the absence of stars. And it's much more evident in the Curiosity Peak image.
whoops. What happened? Oops.
We have so far. There's not. We still don't have much. We don't have much in live chat. Okay.
Now, the graininess in the image is from noise, but that's where when we take multiple images and stack them, and we get the noise doesn't increase that much, but the good image, the good electrons do. So we get much more smooth and vivid image.
To be fair, if you think your image is grainy, you have to look at mine.
Okay. Okay. Well, if you really want to beat yourself up tonight, okay. Yeah. Anyway, like Vivek said, you can see around it this blue area too, and then there's dark nebula dust, which makes it a very interesting. When you have a good image, it's just very vivid, very full of subtleties.
Well, my grain's due to the light pollution, which is what we're trying to show.
Yeah.
Okay, did your 2 minute come in yet?
No, I started a little bit after you.
Okay, yeah, my 2 minute just came in.
40 seconds, okay.
And it kind of looks the same, so it doesn't really matter.
Uh-huh.
Well, wait for your 2 minutes. It's going to be pretty exciting.
Yeah, it's coming.
Perhaps tomorrow you could just set up a sequence and image it.
Yeah, it kind of makes me want to do that, really.
Yeah, that'd be great. Yes.
I think the
scale
Doug,
scale
is good.
Doug, check the chat.
Okay. Yeah. Okay. Sherry says thanks, and such a display we don't see anymore. Okay. Well, glad you could make it, Sherry. By the way, where is Sherry? Did she tell us where she is? Yeah. Somewhere in California, I guess, or I don't know.
She said, let me scroll up the chat again. Manhattan Beach.
Oh, Manhattan Beach. Okay.
Okay, but speaking of which, you have your 2 minute there, and I have my 2 minute. And
yeah. Okay.
It's not even a comparison. It's pretty clear.
Okay, I'll zoom in a little bit to make it same size.
Yeah.
Okay.
That's
you're gonna see it the same magnification as Vivek's image in just a second. There's a little bit of lag through the internet and YouTube. Okay, there we go. Yeah. Okay. Yeah, quite a bit of difference. Yeah.
The type of target you would image at Curiosity Peak. Yeah, this would be a great object for you to image.
Okay, anybody have any questions about the Cocoon Nebula or anything related to light pollution? Not that we are the world experts on light pollution, but we definitely know what difference it makes.
I mean, yeah,
I
anyone
think,
can.
the way I look at it is astronomers are kind of the canaries in the coal mine to let people know that light pollution is there. And then, I think people need to learn more about it and the effects that it has on a lot of things besides our view of the sky, on our health, and on the wildlife, which most of us like to see. Wildlife, yeah. Okay. Oh, good, Lynn. I'm glad you enjoyed it. Okay. Yeah, that's definitely a favorite object, the cocoon. It's got a real kind of maroon color in it. Very, very interesting. The range of color from blue to maroon.
Hydrogen alpha plus reflection plus hydrogen beta.
Hmm.
Color in it.
What is the hydrogen beta? That
Hydrogen.
I know, but is it red or what effect is it?
Hydrogen beta is 486 nanometers. It's blue.
Okay. Oh, it's blue. Okay, unlike the hydrogen alpha.
So it kind of tempers it out so that it's a little more pink. The
Hmm.
the hydrogen emission.
Okay. Oh, we got Philip Canfield from Tucson. All right. Glad you could join us. Thanks to Betsy for inviting Philip.
Okay. Are we ready to go on to the next object?
Yeah, that's M15 the Pegasus Cluster.
Yeah, this is gonna be a little. Yeah, that's gonna be an interesting one.
Okay, so this is a star cluster.
Yep. So it's not like a nebula. It's gonna be a little more resistant because it is stars, but it's gonna be a pretty stark difference.
Oops, sorry, let's just go off. Oh, this is a globular cluster. Okay.
Another meridian flip. This is gonna be another meridian flip.
Okay.
Just for your information.
Could be. Okay. Well, it didn't go anywhere, so I think there's some. What does that say? RCW 32?
Let me check.
Okay.
No, M15 is not RCW 32.
It's not. Okay.
No, it's the Great Pegasus Globular Cluster. So that's an object.
Okay. Well, okay.
Okay, I started to get it now.
Okay. Well, we're just telescopes moving right now. Okay.
Okay, I'll let you. Light solving takes a while.
Whoa.
How long is it taking?
This is also close to the meridian. Just looks like almost just barely past the meridian. Okay, yeah, well, I see yours. Okay.
The plate solving's failing, so I have to cancel it. Okay, I'm taking manual control of this.
Okay, yeah, we don't really need.
We don't need to be exactly centered for this one. This one,
Yeah, okay.
just a cluster, you know.
Stop it right there. Okay. Yeah,
We'll do 30 seconds on this one so we don't overexpose the cluster.
Okay, 30 seconds. Okay.
Yeah. Then we'll see how bad it is compared to here.
Well, globular clusters shouldn't be that different.
You'll be surprised.
Okay.
Is that your plate solving image?
Yeah.
It looks better than my 30 seconds.
Really? Okay. Wow.
Yeah. That's what we're talking about here. Okay, I got a pretty good 30 seconds. I'll let you get your 30 seconds in. Can you zoom in on the cluster?
Yeah. Oh, we got Ernie. Well, welcome, Ernie. I'm glad you were able to make it.
Okay. Don't need to zoom in? I can zoom in on it.
Yeah. Just want to make a little plug. Ernie Cowan is with us, and he was up here today taking pictures at Curiosity Peak, and he's doing an article for the Union Tribune next Sunday. Okay, Lynn.
Okay, we have
added that. Okay.
We have a comparison now. It's unreal. There's a lot more stars in the globular cluster on your image than mine.
Okay, mine's on the right?
Yeah.
Yeah, okay.
Well, you haven't seen it yet.
Oh, okay, yeah, I don't think so, right.
But,
yeah, I think it's just the first image is coming. Oops.
Okay, what is plate solving? Okay,
huh?
so I'm answering a question in the chat.
Oh, okay.
Plate solving is when you have you take an image and then software analyzes that image to look for how the stars are positioned to determine where in the sky that image is. And then after it gets those coordinates, you can use that to fine-tune where the telescope is pointed. So we're using plate solving to go to the targets so that we can get them centered and then we can start exposing them. So that's what plate solving is.
Yeah, and the software actually does that automatically. It figures out how the telescope needs to be moved in order to get the target right in the center of your field of view.
I'm zooming in to the same level on my image too.
Okay.
It's not even. It's the difference is huge.
Yeah, it is. It looks like a small cluster on the left and a big cluster on the right.
But it's the same exact cluster.
Yeah. Ernie's moving to Julian. All right. Welcome.
That being said, I could take longer exposures, and if I take a long enough exposure, then I'll get the one on the left looking real nice. Mm-hmm. Yeah, I just need to get a lot more data. But
yeah. Although globular clusters are something that are popular for people who live in more light polluted areas to look at, because you can definitely see them and enjoy view. But they're much better in a dark sky location.
Same with imaging. You can image them pretty well. You just have to take a lot of data on them to clean out the noise, and then the noise from light pollution and the gradients and dealing with all of that. Then getting a lot of data, then you can get a nice image of the cluster. It's just going to be easier from a dark sky site, but yeah.
Does everybody understand what we mean by noise? Because people may wonder, well, gee, I don't hear anything.
Well, I mean, if you look at the grain on both images, I mean, that serves as an indicator. If you compare the grain with how bright the nebula or galaxy or this cluster is. But yeah, I hope we can make it pretty clear how much light pollution affects these clusters. Yeah.
Yeah, there is noise that comes from the equipment, and when we say noise, what we mean is, things that are in the image that are not really part of the subject that we're shooting, the target. They're just it could be random noise caused in the electronics, but then there's also the noise that comes from the sky, from the light pollution, which is basically undesired, photons that are or electrons in the sensor that are firing.
Yeah.
We really don't, it should be dark, but there's something there. But what's there is just interference. Basically, it's like static, kind of
But on these cameras we have here, they're very low. There's a very small amount of it. Especially the camera on the left. So surprisingly, it's very, very low noise. So the main contribution of light pollution here is basically going to be a lack of data and the light pollution. The data from the sensor itself on these sensors is pretty low, especially the one on the left. Okay, any idea how many stars are in that cluster? Tens of thousands to 100,000. Well, I don't know the exact figure.
Yeah, if you Google it, M15 is the name of the object.
But it's going to be in that range. There's quite a few stars in it.
It could give you that information as well as the distance. And
actually, give me a sec.
It's in the Milky Way. All the globular clusters are in the Milky Way. They're all pretty much around the periphery of the Milky Way, and they're very old. They were, there's a lot of theories about them that they're quite possibly are.
Okay, I got the number.
Yeah.
100,000.
100,000. Okay, it's a pretty big one then. Yeah.
Okay. Yeah, I think we can go to the next object.
Yeah. Okay.
What's next?
If you lived on a planet that was going around one of those stars, it'd probably be perpetually daytime. You wouldn't be very dark because of the density of stars. Okay, so we're going to go. Our last target is the Deerlick Galaxy. Okay, so we haven't been to any galaxies since Andromeda tonight.
Okay, I'm going to stop looping and slew. Yeah, that's the last target, right?
Yeah.
Okay, I think I missed some questions. Someone's asking Betsy's asking if I'm planning to study astronomy in college. Yes. That's the answer. Yeah. Well, I'm too far down the rabbit hole to go back, so.
Okay. All right. Let's go there. Oh, it just moved a tiny bit. I have a feeling it's not.
Okay.
It should have moved quite a bit, right?
It should move to the other side of the meridian.
Yeah, okay, well it didn't.
Then you've got a problem.
Yeah, it's still on the globular cluster. Okay.
You need to put a space, I think.
Need to put a space. Oh, okay. Okay, well I'm gonna stop it then.
Spaces are only for no space is only for Messier objects.
Okay, wow, okay. All right, now it's saying UGC 12113. Is that the same thing?
Yes.
Okay.
Okay. My plate solving is failing.
Okay.
I need to take longer exposure.
Yeah, okay, now we're moving quite a bit, yeah.
Okay, let me get this. This is far from the Milky Way, so getting stars for plate solving is a little more difficult because there's less stars. So I'm going to take a longer exposure to get it there. This will be the last object, and it's pretty faint, so it'll be interesting to see how it shapes up.
I think, haven't we looked at this in another star party? I think.
Yes. We've looked at it before, yeah.
Okay.
It's one of the few galaxies in the sky right now that I can see from my backyard. Yeah, I have to keep in. My backyard has trees, so you know some galaxies I would want to look at. They're not exactly available. Yes, I think M33 might be visible. So after this one, we can go to M33 and finish off the star party.
Okay. Yeah, that would be a good one because that's a fairly faint galaxy.
Yeah, so after this one, we'll have M33.
We're doing 30 seconds on this one?
Let's do 60.
60, okay.
I'm still have to go there. Still gotta go there. Yeah, but we'll finish off with M33 and that'll be it.
Okay.
We're 10 minutes away. Okay. Almost there.
Okay, we're imaging. Okay, we got a little trace of the derelict there from the plate solving. Plate solving is what, a few seconds only, just long enough to get the pattern of stars. The computer can analyze and nudge the scope a little wherever it needs to go.
Okay, I'm starting my 60 seconds. You're already 40 seconds.
Okay. Yeah.
This is going to be quite the comparison. Okay.
And also be interesting to see whether the fainter galaxies that are in the background show up, how they show up.
Oh, they'll show up.
Yeah. But how much you can...
Yeah.
How detailed.
I see them in both plate solving. Okay, that's quite nice.
Okay.
I've got 30 seconds left on mine. Okay, yeah, that's a pretty good image. You can see the other members. Oh, we have Stefan's quintet in there.
Yeah, okay.
How about you show both of them on the screen? Let's get it there so that we can see both. And you can Stefan's quintet is basically 5 interacting galaxies very close to the derelict, which is the one down over here. So,
and then there's some other galaxies right here. These are more distant galaxies.
I didn't even realize my 60 second exposure loaded.
Oh, okay.
Because it made absolutely no improvement.
Oh, really? Oh.
Yeah, I mean this is probably the most stark comparison we've done tonight. It's even close.
I'm looking at my laptop trying to see the Stefan's quintet.
Well, I haven't taken it hasn't loaded for you yet.
Oh, okay.
But you'll see
lagging. Yeah.
Yeah, my quintet looks like little tiny fuzz, very, very, very barely show up fuzzes. And the derelict is barely there too. Yeah, this is very stark. You're taking 60 seconds, right?
Sorry?
Yeah, this is very stark comparison.
This was 60 seconds, yeah. This little group of galaxies up here, this was discovered by a French astronomer in the 19th century, I believe. And his last name was Stefan. And, or maybe it was his first. But anyway, he was the first one to discover galaxies in groups, clusters of galaxies, which now we know there are many, many, many of them in the universe, but because galaxies can be held together by mutual gravitational attraction.
Yeah.
I don't know if it says something about their history either, their formation.
Yeah, it does. I mean, we have those 5 interacting ones over here, and we have the derelict over here, and we have that other cluster. And so we got basically 2 distinct clusters on the screen. But obviously the Julian image just takes the cake here. You can see a lot more on the derelict. The Stefan's quintet is quite clear. You can see that other cluster near the derelict pretty clearly. So, yeah.
Yeah, but one of the things that's nice about when you have galaxies like that in proximity, it gives you a 3-dimensional perspective, because those are not just tiny galaxies; they're just a lot farther away. So that if you understand that and you look at it, and you're like, oh, okay, the big galaxies in the foreground and the little galaxies are just much farther away.
Yeah, I think. Yeah, I think we can go on to the final target now.
Okay, and that's going to be M33.
Yeah.
And M33 is another one of our neighbors.
It's in the local group along with Andromeda, and it has a gravitational association with Andromeda too. So okay,
let's see. Now we don't want space with the M33, right? Yeah. Okay. Okay.
I've got it slowing now. This will be the last target.
And M33 is in Triangulum, the constellation.
Yes.
Which is a more northern.
Yes.
Part of the sky.
Let me see if making sure I can see it.
Okay, is that look? Hopefully, yeah. Plate solving is there. It is. Okay.
I'm still plate solving there.
Now, one of the things you'll notice too is how different galaxies look depending on what angle our perspective is in relation to their equator, or what do you call it? Their equatorial plane, or I'm not sure. In other words, it's kind of like looking at if you're looking at a dinner plate, straight on, it looks like a big flat circular object. If you look at it edgewise, it looks like almost a thin line. So
it's the galactic plane, like the
galactic plane. Okay.
Yeah, I've got M33 on the screen on my end, and it looks kind of blobby.
And how long are we going to expose M33? 60 seconds?
Let's do 60, yeah.
60, okay.
I'm still going there, though. It's almost there. It's on the screen. Okay.
And one of the things about M33 is it doesn't have a black hole, right, at the center?
No, it does not. We haven't detected any, at least.
So what's holding it together?
Well, you don't need a black hole to hold it together. That's not the supermassive black hole is supposed to have a role in the formation, but it's not. There's a lot more mass in the galaxy than there is mass in the black hole.
Yeah, so it's just the amount of stars in the center of the galaxy.
No, just the galaxy together, because you have to imagine this galaxy has a center of mass, and that center of mass is very large. So you don't necessarily need a supermassive black hole to keep a galaxy together. They'll do need some dark matter, though.
Okay. All right, we just hit 60 seconds, so we should.
Okay, I just started my 60 seconds.
Okay, there's the image.
Pretty good.
Okay.
That's great.
Yeah.
That's pretty good. I'll see how sad mine looks.
Wow, that makes me want to image it.
Well, everything we're doing is making me want to image it now.
Yeah, we are imaging, but when we say imaging, we mean doing, a few hours of exposure time on an object, or even up to 20 or 30 hours.
Well, obviously not a single exposure, but in total integration, if we add up all of the exposures. But I feel like every time we go to an object, you're going to be like, oh, I want to image that object.
Yeah, I do.
I wish I could image it, but I've still light polluted. Okay, I'm almost 10 seconds until I'm done.
Okay.
We're gonna see how stars.
This galaxy provides a lot of detail because it's closer to us.
Okay, so my image just loaded, and it looks. This is okay. I said the last object was the most stark compared.
Oh my goodness! I can't believe that. That's.
Did you see it load?
Yeah.
It doesn't. This is the most. Okay, I said the last object was the most stark comparison. This is even more stark. You can't even see almost any of it. Just the core with the.
Yeah. Yeah.
That's. Yeah. So. I guess we're ending on this. Very stark. It's not even the same. What is this?
Yeah, it doesn't. It almost looks like a little nebula or something with a, or a.
It doesn't look
Yeah.
like it doesn't look very much like itself.
Yeah.
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 Well,
So,
that's light pollution for you.
yeah. And in M33, we can actually see a lot of areas where stars are forming. They're kind of reddish areas with a lot of hydrogen.
Well, with the way we have this set up, we don't have the color balance. I'll show it, but
Yeah.
if you look at if we zoom in on Doug's image, which is much better, that area over there, that's a nebula in M33. And there's quite a lot of these little pockets across the galaxy where you see that red nebula. But in this image, I don't know what to say about this image.
Well, we'd have to stack a lot more and process a lot.
You have to take a ton of
Bring it out.
integration
Yeah.
from light pollution to get. Meanwhile, one exposure looks really good from Julian. So, yeah.
But we might do like 100 exposures or more.
Yeah, you need quite a lot.
Yeah, and then stack them.
Hours of integration.
Yeah.
So
we don't have to sit there and while it happens, because thanks to computers, digital camera software, we set it up and we let it go all night, and we come and check it in the morning and see what we've got.
Yeah. So this is the final comparison.
Yeah. That one's a really, really good illustration of how important, how we're able to basically look out and see what's out there in the cosmos.
Yeah, maybe I'll screenshot this. Let me do that.
Yeah, I will too.
Okay. Yeah, that's a very cool comparison.
Yeah. Okay. Well, maybe we should say a little bit about our next star party.
Yeah.
Before we say goodnight. It's going to be next Saturday night, and of course, weather is a huge factor. If it looks like it's going to be cloudy or the marine layer is going to roll in, and we know that with a fair amount of certainty, then we are going to postpone it. We're not fickle about doing these. We plan them and we prepare, but we don't control weather. So that's the intervention that we are watching somewhat nervously, throughout the week. So we will, if we do have to do that, we'll post that on our channel. And if you become a subscriber to our channel, then you will get to the notification both about the event and any cancellation or postponement. And we also send out emails too, and we have our Facebook, and we also have a great website for Julian Dark Sky Network, which besides talking about light pollution, it has images that are taken by people, both astronomers and local photographers, and some tips on how to practice good lighting, and also updates on our own goal of becoming an international dark sky community, which we expect to become by the end of this year. We're certainly so anyway, I want to thank everybody for joining us tonight. It was great to see returning people and a lot of new people too. So
yeah.
we see you next